We're going to be discussing kind of how the lineup runs, what you can expect to see as far as the products offered, some theory of operation, some what to look out for in the field. A lot of what we're going to discuss is going to kind of cover residential and commercial equipment, again, theory of operations. So happy St. Patrick's Day to you too, John. Hope everyone has a great day. It's my understanding that the stimulus checks are dropping, so hope you all find a pot of gold in your bank accounts this morning. I have yet to check, but let's keep our fingers crossed. So we're going to jump in. So Wallace Associates, manufacturer's representative. We cover a lot of very high quality brands. Up until this year, we've been associated mainly with hydronic heating. So if you're moving hot water for any reason, we were your guys and girls. So again, Bell & Gossett, Lochinvar, Gould, Danfoss, Aquatherm. We've recently become the master distributor and rep for Panasonic HVAC in the United States. So we are now offering a full line of refrigeration, heat pumps, indoor cooling, as well as VRF solutions as well. So kind of a new thing for us. It's been very good so far, and we look forward to growing as the indoor air side stuff picks up. Let's get started. Okay, so again, commercial, industrial, residential water heating, domestic water, pressure boosting, radiant heat, hydronic pumping, wastewater, heat exchangers, polypropylene systems, as you saw with the Aquatherm line, expansion, vibration, noise, and seismic solutions is going to be something we offer as well. We have two offices. One is located in Franklin Lakes, New Jersey, northern New Jersey, not far from New York City. And we have an office and warehouse in Plainview, New York, which again is not far from New York City, located on Long Island. So we're going to be talking about condensing boiler service and maintenance today. Again, a lot of what we're going to cover is going to be theory of operation stuff. We're going to give you guys exposure to the Locknbar University website as well a little bit later, which is going to kind of open a lot of your eyes. If you haven't been registered already, I highly recommend that you do. We're going to be watching some of the content from that during this presentation, and it's going to give you a good idea what to expect. So first off, we're going to say, why do we use condensing boilers and water heaters? And moreover, what does that mean? Why do we use that? So a condensing boiler and a water heater are going to have some distinct advantages over what we're going to say is a standard efficiency AFUE piece of equipment. So gas condensing boilers and water heaters provide the highest possible efficiency. They offer simple, cost-effective solutions to expensive ventings. And we're going to cover that in a lot more depth in a couple slides. Cramped boiler room issues with a small footprint, and then modulate to match the boiler input. So let's start from the top. So efficiency, when we discuss efficiency, efficiency is measured in our industry by something called the AFUE, or annual fuel utilization efficiency. You're going to see that represented by a percentage. Okay, so you'll see a lot of numbers get thrown around. Oh, we got 85%, we have 90%, we have 99%. Easiest way to really break that down and make it easy to digest is, say if you spend $1 on fuel. Okay, if you're running an older cast iron heat exchanger atmospheric vent boiler, it may be running at 80% efficiency. So what that means is, out of that dollar, you can say that 80 cents of your dollar got turned into energy in the form of hot water, and 20 cents of that dollar got wasted as latent flue gases just blowing out into the atmosphere. So when we discuss the Lochinvar products, when they're installed and they're running the way that they're supposed to, you can get up to 99% efficiency. You know, so say 90, 95%, you take that same dollar, and what you're going to see is that 95 cents of your dollar is used as energy, right? It's used to heat the house or the space. 5 cents of your dollar is flue gases, right? We're never going to get to 100% efficiency, but we can get very close. So the advantages are that if you're taking an older piece of equipment and you're replacing with a condensing piece of equipment, you're going to see significant, very significant fuel economy improvements, which translate directly to dollars saved and returns on investments. So expensive venting systems, we're going to discuss this at greater length because of the technology that we use to create that condensing, you're able to use materials that you ordinarily wouldn't, and save yourself a lot of money. It saves time on install. It saves money on your venting actual install costs. Gas condensing boilers, particularly the Lochinvar line, are typically much smaller than an average, again, atmospheric cast iron heat exchanger. This can be good, and as a former installer, this can also be kind of bad sometimes, because you can shoehorn these boilers into very small spaces. So if you're a service tech, you know, sometimes you may walk into a room and kind of scratch your head. But again, these offer solutions. You know, we're talking about BTU inputs on our product line from 55,000 BTUs up to 6 million. And for what they are, they're very, very small. So a 6 million BTU input boiler, in past days, you would walk into a boiler plant and see it's the size of a school bus, you know, size of a small truck. It's very, very large piece of equipment. Nowadays, because we're able to squeak all that energy out of the heat exchangers, you don't need a giant footprint anymore. So typical boiler size you're looking at, if it's not a wall hung, a big filing cabinet at best. So again, saves economy for your install. Your boiler plant footprint is shrinking significantly. And the gas boilers condensing modulate to match input, again, is one of the things, it's one of the ways that we kind of stack that efficiency. We take our modulation, we take our condensing, and we take the pump and flow requirements. And being able to modulate and control all three of those factors, again, is one of the things that gives us that top efficiency, that gets us into that 90, 95, 97, 99% efficiency. These numbers are all verified. You know, we wouldn't publish them if they hadn't been proven already. So. Okay. So we discussed this a little bit. For water heating on the other side, 95 to 98% efficiency. Gas condensing waters are the most efficient ways to heat domestic water. So the technology that you see for a gas condensing modulating boiler are going to be the same for a water heater. The big differences between them is going to be, of course, materials, because you're dealing with potable water that's going to be going out through faucets and fixtures. People are going to bathe in it, they're going to cook, they're going to drink it. So where you would see a boiler, you may have some cast or some iron or something like that. You're going to have all stainless and bronze and brass throughout a water heating piece of equipment. Okay, Lochinvar's lineup. These are the night boilers. Again, you can see there's a lot of different offerings for the nights, from wall hungs all the way up to floor mounted. There is also the Noble, which is a wall hung boiler. There's a Noble fire tube combi. From 110 up to 199,000 BTUs. Again, this is a fire tube combi. So what this piece of equipment is doing is this is providing space heat for a home as well as hot water. There's a brazed plate heat exchanger inside of this cabinet that allows you to run your domestic hot water as well as creating heat for your space. Again, all of Lochinvar's products are designed, engineered, and assembled in the United States, in Lebanon, Tennessee, by American people in America. There's a 10-year heat exchanger warranty with 5 years on the parts. In addition to the Noble Combi, we also have the Noble Boiler Only, which is an 80,000, 110,000, 150,000 BTU input. And we're not going to spend too much time on the small wall hug stuff. We're going to try and focus as much as we can on our commercial offerings. Again, here's the nights. So you can see the nights on the floor mounts up to 285,000 BTUs. On the wall mounts, the 399,000 BTUs. All of the night boilers at this time are fire tube. And we have the addition recently of the Night XL commercial boiler, which is a 97% thermal efficiency, from 400,000 BTUs up to 1 million BTU input boiler. Okay, so when we're talking about a commercial application, when we talked about that diminishing footprint, this is a perfect example. This boiler is very small for a large input. And again, thermal efficiency of 97%. You take that dollar, 97 cents of the money that your customer is going to spend to heat their space is going to turn into energy. One of the advantages of this too is you can go up to 150 feet of equivalent venting, which is beyond what you see with anybody else's product. Again, the Night commercial boiler, that the XL, is going to be available now. So take a look at that. If you have any interest, please feel free to reach out and we can get you that. We can provide you a lot more in-depth information. Okay. The FTXL boiler lineup goes from 399,000 up to 850,000 BTUs. Again, this is the light commercial boiler. We're located, well, I work in the northern New Jersey area. There are plenty of McMansions around where a 399, 500,000 BTU boiler is going to be perfectly acceptable. And this is a great solution. It's a fire tube boiler, again, with lots of inputs from 399,000 to 850. So you can see we're kind of blending the line between the FTXLs and now the Night XL, excuse me. Fire tube versus water tube, and the difference between those two, let's talk about that for a minute. Let's see if I had a graphic. But essentially, when we say fire tube versus water tube boiler, is we're discussing what's in the tube. We have some good cutaway pictures of the boilers that we could show you in a few slides, but essentially, there's two different ways that we can exchange heat to the water for space heating applications or domestic hot water. And essentially what it is what's in the tube. So we're either having a tube full of fire surrounded by water that's exchanging the heat, or we have a tube full of water, which is having the energy in the form of flame, heating it directly that way. And the flagship line for commercial heating is the Crest condensing boiler, from 750,000 BTUs up to 6 million, okay? And every BTU input in between. Again, this is gonna be the flagship condensing boiler. This is gonna be CSD1 compliant. This is native for Modbus, back then MSTP, built into the controller. So again, this is gonna be the commercial product that you see going in the most. Now we do have some crossover here, right? 850,000 BTUs, 725,000 on the FTXL. And we have 750,000 and 1 million on the lower end of the Crest. Would you use an FTXL in place of a Crest? Well, it depends on your job. The Crest is going to have a bigger footprint than an FTXL. So again, if you're looking at an application where you've got a ton of piping to squeeze in, you don't have a big boiler plant, there's stuff there that's being decommissioned but not demoed, perhaps, the FTXL is going to be a great choice. Because again, you're going to be able to slide that in. It's a large filing cabinet sized piece of equipment. And you're going to be able to put all those BTUs into a very small space. So again, Crest condensing boiler is going to be CSD1 compliant out of the factory. It's going to have all of your building automation controls standard. So again, this is the flagship line for our commercial stuff. The Armor product family is our water heating product family. And if you just kind of briefly look over this slide, you're going to see that the Armors look very similar to the Crests and the FTXLs and the Knights, because essentially the cabinets and the layout are all very similar. Again, the condensing technology, the modulation, the turndown, all that tech leads across the product lines, and we're using it all similarly. So again, the cabinets are very similar. The biggest differentiator is going to be what kind of materials are being used for a water heater, again, because you do have the potable water. You want to make sure that you're, again, only using bronze, stainless steel, and brass in order to make sure that you're not using anything that people can't drink from. Okay, so the wall mount water heater, 125, 200,000 BTU input. Again, this is kind of residential, so we're going to simplify that a little bit. And the Armor condensing water heater is shown here with a tank, 151,000 BTUs up to 800,000 BTUs. Again, these are all offered in natural gas, and they're all offered in liquid propane if that's popular in your market. Okay, then we have the Armor 1.25 million BTUs all the way up to 4 million BTUs. So again, the Armor product lines trying to follow the trend that you see in the boiler lines. Again, lots of different BTU inputs up to 4 million. Here we have the Shield commercial water heater. The Shield commercial water heater is essentially meant to be more of a drop-in replacement for our cylindrical type of standard water heater. Again, these are modulating condensing. The fire control group and the burners are built in, and there's a storage tank included. So it's basically a one size fits all. These are tremendously popular in hospitality and restaurant applications, again, where you want to get your storage and your fire control and your heating all in one package. So where are these typically used? Okay, so we've got some nights here. One night with a storage tank, one night you can see is doing some radiant heat over there on the left-hand side. Again, these are single-family residences. You got your entire boiler plant in a very small space. You're hardly taking up any room. You got a manifold on the wall, and then you can just squeeze that boiler in, leaving a lot of room. That's kind of that slide we discussed before, where it is a significantly smaller footprint. We have an armor plant in the Norwood Apartments in Rockville Center, New York. Piping Rock Country Club, again, some good examples. On the right-hand side, you see the Aquatherm product line. Again, that is polypropylene piping. It's offered for lots of different applications for basically anything you need. Easy to install, significantly cost effective because it's going to save you a ton of time and labor. But we can discuss Aquatherm if you want to have any interest. You can give us a shout on that. A couple more examples. Again, we're just demonstrating here the extremely small footprint. And again, too, is the boiler's ability to run as a plant, right? You're going to see in most of these examples, we have more than one piece of equipment, and we can kind of cover redundancy in a few slides. So Vanderbilt University, this is a water heating plant. All these water heaters running together. So earlier in some of the slides, we discussed that venting is more flexible for a condensing boiler. So on a condensing boiler, you have the list of approved materials as PVC, CPVC, stainless steel AL29-4C, rigid or flex, and polypropylene. The reason why we are so much more competitive with PVC is the condensing technology, okay? Sorry about that. All right, we are unpaused. So PVC, CPVC, why can we use PVC if we're using a boiler with an input and hundreds of thousands of BTUs of input? Okay, so solid core, Schedule 40 PVC pipe will be well above the threshold for the outlet temperature from the flue pipe in a condensing boiler. So why do condensing boilers have such low outlet flues? Like, why does the flue pipe so much cooler than an atmospheric boiler? When we talked about that 80% turning into heat, 20% turning into energy, we're looking at condensing. So we talk about condensing. What we're doing is we're capturing latent heat in the heat exchanger rather than letting the boiler gases change state in the flue pipe. So because we're capturing the energy in the heat exchanger, our flue gases are typically very low. Ordinarily, you're not going to see flue gases above 140 degrees, and even that's a little high. So we're able to use PVC, CPVC. This is, again, subject to your local regulatory. In the New York City, the 5-borough area, PVC is not allowed. I would expect that we're going to see that trend in major metro areas across the United States, depending where you guys are listing from. So again, PVC is acceptable. And what's the advantage of PVC? Why do people get excited about PVC? Well, it's significantly less expensive than putting in AL29-4C. Easier to work with. You know, the plastic pipe is sometimes a little more forgiving with getting your venting together and getting everything mounted and hung. And polypropylene. Okay, what is polypropylene? If you haven't seen polypropylene, it's typically called polypro. It's going to be like a dark gray or almost a black looking pipe. And again, this is a plastic material pipe that is significantly lighter. It's going to be more cost effective than AL29-4C. The advantages of polypropylene is that polypropylene does not burn and create toxic gases. Okay, so let me backtrack a little bit. I know I just said that we don't see flue gases that are hot enough to ignite the the PVC. Standard solid core Sched 40 PVC will not be ignited by the flue gases. However, if there is a fire in the boiler plant ancillary to the boilers, Schedule 40 PVC will burn, and when it does burn, it creates toxic gases, which is the reason why it's not able to be used in the 5 boroughs. You don't get that with polypropylene. So polypropylene is kind of in the middle between Al29,4C and PVC. Venting configurations. This is a good slide that kind of shows a little bit of everything that you can do. Again, that forgivingness of the condensing boiler. So upper left-hand corner, you can see direct vent, where we're going to have a fresh air intake for our combustion air, and our flue gases are exhausted through the main plane in the side of the building. You can see you can go right out the side, you can go out through the roof penetration. Flat roof, doesn't matter. Concentric vent kits. Concentric vent kit is essentially a kit that you're going to use, if you haven't seen them, where you need a single penetration to gather your combustion air and expel your flue gases using a conical device, essentially, that pulls the flue gases through one side and pushes pulls the combustion air through one side and pushes the flue gases out through the other. And again, you can push that out for sidewall venting. That can go out through the roof as well. We can switch it up. We can do vertical venting with sidewall air. We can do room air. So again, we don't need to necessarily have our flue gases expelled and our combustion air coming through the same plane. So if it's easier for you to take your fresh air intake from the side of the building and vent out the top, perfectly acceptable. And on the lower right-hand side of the slide, you see room air. Okay. So again, the boiler needs air to create the combustion. Obviously, air and fuel and a source of ignition are what we need to kind of make fire, right? If you have enough room in your boiler plant for the boiler to get its necessary cubic feet of air per minute, then you can pull room air. Again, this is normally seen in bigger boiler plants where you may have a louver that's interlocked to the boiler. So every time you get a call for heat, that the louver is going to open and it's going to allow fresh air to flow into the room. Or you may just have a big enough room that you can just pull your air. You're not going to see room air for smaller applications where you have a tightly sealed room. There's a couple of doors in between the boiler and a fresh air source. At that point, you're going to need to really look at pulling all outside fresh air. So, okay. Now, combustion venting is very important, and if you were to say what's the #1 thing that screwed up the most reliably on an install, I would say it's probably venting. Now, this is obviously, this slide is a little extreme. Hopefully you never come across somebody who's venting their boiler inside an enclosed space, but again, flue gases contain carbon monoxide. Carbon monoxide is an odorless gas that is deadly if you breathe it in your air. So we want to make sure that we vent the flue products outside of the building, and very, very important. There is in every manual you get, you're going to have a good layout of what venting is acceptable, how long you can go, where to put it, where not to put it. Okay. Again, the manuals are a very good source of information, and they're going to allow you to see what a good location is and what isn't. We're going to show you an extremely bad location right here. Okay, so this is the aforementioned Concentric kit. You can see that there is a cone with the tube right in the middle of it, and what this is doing again is the flue gases are coming out of the cone here, and we're pulling our combustion air in through the back of that kind of bell-shaped thing. We have a better picture of this coming up in a few slides. So this is a great what not to do one. It's like, let's figure out how many things are wrong with this picture in one shot. Well, for one thing to start, we are expelling flue gases, and those flue gases do contain carbon monoxide. So you want to make sure that you're not directly adjacent to a fresh air intake, say a window or a door. We have, well, basically a window and a door within what looks to be about a foot of our flue gases, so that's a bad idea. We've got a sillcock for water right above it that could potentially just drip water over onto it, and a laundry vent literally right next to it. You can see that there's plenty of laundry lint down on the ground, and I will absolutely guarantee that as this boiler runs, if it's running while the laundry is running, that fresh air intake is pulling laundry lint into our heat exchanger. So all that efficiency that we got is pretty much going to be lost because that heat exchanger is now going to be clogged full of laundry lint. It's going to reduce the lifespan of the unit, and it's certainly going to reduce the efficiency of the unit as well. Again, venting, one of the things, actually on this slide, we can go back to this one. Good to remember as well, and again, you can go more in depth with this, all the venting material, all the venting lengths, all the venting best practices are going to be laid out for you in the manuals that come with your equipment. So during the winter months when these boilers are running, these boilers and water heaters, the flue gases are going to contain some water, okay? So it's not uncommon to see water dripping out of a condensing boiler's flue pipe. Now, you want to make sure that that flue pipe does not go above a path of public egress. We're talking about stairs, steps, sidewalks, what have you, because you do have the potential to turn that space into an ice skating rink during the cold winter months. This is a perfect example. Again, reading the manuals and familiarizing yourself with best practices is going to be helpful. We can do a venting specific class in the future if there's interest, but again, be aware that venting is potentially dangerous. Again, if you can't find it in the manual, reach out to us. If you're local to Wallace, you can give us a call. I will be happy to come out and meet you on the job site. We can lay out your venting. We can tell you how far you should go, where you should put it, what type of materials is best for your application. Again, that's what we do. We're always happy to help. And I'm in the northern New Jersey region. We cover all the 5 boroughs, all Long Island and New Jersey down to South Jersey. So again, if you have questions and you're in our area, don't be shy. Please feel free to reach out. Here's a couple good ones. So this is a better picture on the left-hand side of a concentric vent kit. So again, you use one penetration for your flue and your air intakes. The flue gas is going to be the portion that is pushing the smoke out. And if you look at this one, the masons were nice enough to go ahead and seal up what they thought was an aesthetically unpleasing gap between the wall and this piece of equipment. However, what they did do is completely isolate the boiler from any fresh air intake. And again, on the right-hand side, we have, this is probably a rough-in. Somebody decided to cover up their intakes with a couple of plastic bags in order to keep them from pulling any kind of garbage or stuff into the equipment as it was being installed, which is fine, but don't forget to take that stuff off. Very important to remember too is snow line. So if you're venting and you're in a subsurface application and you punch out through a sidewall and you come out 3 inches above grade and you live in a part of the country where there is significant snow accumulation, you're going to have issues, because when the flue or the fresh air intake get restricted, you're going to have all sorts of combustion issues. You have a lot of failures. And again, you would be surprised how often this happens. I know all of us joining us in this have some exposure to the boiler industry, so I'm sure we are all kind of shaking our head at some boneheaded thing we've seen done. So again, these are some particularly bad examples. But again, be aware, don't obstruct your intakes, don't obstruct your flues for certain, and make sure that you have significant enough clearances above snow, even stuff like landscaping mulch or anything like that. If you're too close to the deck, you do run the potential problem of pulling stuff in through your intake air, and all that stuff's going to get pulled into your equipment and it's not going to run efficiently. Okay, review the venting system at installation, at startup, at service. Again, the National Fuel Gas Code Book is going to run through this very comprehensively. But again, also in your install manuals, there is going to be a section that lays out exactly what the size of the pipe you're going to need is, how far you can take it, and your best practices for where you should be landing everything. Again, on PVC pipe, you're never going to want to see anything leaking. Okay, you're going to want to prime those joints. You're going to want to glue them together. If your installers are not experienced with larger size PVC fittings, you know, they need to make sure to seat them correctly and then kind of keep them seated until your sealant is adhered properly. Okay, because I mean, if you've ever done that before with, like, say, 4-inch flue pipe, and you stick it in and you seat it to the bottom of that fitting, it'll push itself out. Okay, so again, this is all best practice stuff. Most of our contractors are familiar with it. But again, as kind of the overseeing authority to this sort of thing, this is stuff that we need to be aware of. Okay, so correct any document venting issues. Again, this is a ridiculous example, but you know what? This stuff happens more often than we'd like to admit. If you do see any issues, figure out what the potential problem was and correct it. Okay, so it's on you to make sure that this is done correctly as a contractor. If you're a GC, again, you need to make sure that venting is taken very seriously, okay? Because there is a potential for a life safety problem. If carbon monoxide goes into a living space over a period of time, people are exposed to it, can be fatal. I'm sure, you know, everybody sees it every winter. Somebody tries to vent improperly, or they light a combustion appliance inside their house because they think they can save money on their fuel bill, and they end up killing a whole bunch of folks, which obviously you don't want to be responsible for. So again, venting is not difficult to do correctly, but it is not uncommon, unfortunately, for people to try and cut corners. So again, we have the responsibility as the installer or the overseeing personnel to make sure that it's done correctly and safely. Okay, so gas input to the equipment. Okay, gas supply requirements are going to vary by the size of the equipment that you're installing. So, for example, a smaller light commercial 399,000 BTU input boiler is going to require less fuel than a 6 million BTU input boiler. And again, gas inlet connection sizes are going to be different based on the size of the equipment that you're putting in. And equipment over 1 million BTUs typically is going to be specified by an engineer who is also going to be specifying the gas piping manifold sizes if you're putting in more than one boiler. So again, a lot of this background work is usually done before we get to it. However, you know, gas, if you don't have the properly sized gas line to a boiler, it's going to result in a lot of issues, and you're not going to be able to get your maximum BTU input. So you may have an example where a boiler will fire, but it's not firing efficiently, or you're having potentially faults, things like that. That can be due to improperly sized gas lines. Again, the National Fuel Gas Code book is very important. And again, read the manuals. All this information is explicitly called out for each individual piece of equipment that you do buy. And again, if you have questions on any of this, particularly gas, venting, install, you can reach out to Wallace Ennis and we'd be happy to help walk you through it. Now, gas pressure, okay? So what we're talking about gas pressure here, if you see on the right-hand side of the slide, there's a crazy looking device, which I hope everybody knows what that is. That is a manometer, okay? What a manometer does is it measures the gas pressure coming to the appliance in something that's called inches of water column. Every single one of you as a contractor or contractors that you work with as a sales or representative personnel should have a manometer. The one that we're seeing on the right-hand side is called a slack tube or U-tube manometer. More often than not nowadays, we see digital manometers, simply for ease of transport mostly. So what you're going to need to do is when you're installing the equipment is you're going to install your manometer on the gas valve of the boiler, and you're going to read how much gas is coming in from your service to your boiler. Okay, so the maximum that we want to see is 14 inches of water column. The minimum is 4. Okay, so and for liquid propane, it's 14 max, minimum 8. Now, it's good to remember that doing the bare minimum is not what we want to see. So 4 inches water column, the boiler's going to fire. You're going to have probably almost certainly issues over time because we can take 2 readings with a manometer. Okay, you can have your static reading, which is the amount of pressure that comes from your regulator to the boiler while the boiler is idle and the gas valve is shut. Okay, so if you come in and you say, I have 4 inches of water column, great, but the boiler's off. What's going to happen when the boiler fires and that gas valve opens? You're no longer going to have your static, you're going to have your dynamic, and then what's going to happen is you're going to watch that inches of water column kind of drop through the floor you're going to have issues. So what you want to see ideally is somewhere in the 7 to 10 range, which is going to give, I think, a 7 to 10 static range. So when the boiler or water heater does fire and it starts using the gas and consuming that energy, you can drop some inches of water column, you're still going to be within the threshold, which is going to allow you, again, to make your proper BTU input. Okay, so condensate. Condensation, let's, all right, so condensing boilers. I'm gonna kind of go a little bit off the reservation here, if nobody minds. Give me just a second. We're gonna grab, good morning, everybody. I'm gonna bring up a video that's going to discuss condensing, because again, we talked about turndown, we talked about condensing, we talked about modulation, but I want to make sure that we really understand what that all means. So we're going to go ahead and break in a video, as we discussed Locknbar University previously, and I want to make sure that everybody gets a good idea what it's looking at here. So give me just a second to bring this up, and then we'll share my screen again. In the meantime, enjoy our bleak northern New Jersey weather. Okay. Okay, so we are having some technical difficulties with that. We will go back to sharing the screen. Okay, so condensate, we're gonna kind of double back on this. So we talked about condensing, we talked about modulating, we talked about turndown. So we also talked about flue gases containing water. So one of the byproducts, one of the ways that we get this efficiency, right, is for a condensing boiler. So what happens is as the energy travels through the heat exchanger in the form of flame, on an older atmospheric cast iron boiler, it would travel through the heat exchanger and it would expel the flue gases into the flue, and it would change state from a flame to a vapor in the flue. Okay? The reason a condensing boiler is so efficient is we allow the flame to change state from a flame to a gas inside of the heat exchanger, right? So rather than having all that heat blow out through the flue, it gets captured in the heat exchanger. One of the byproducts of that is condensate. Okay, so a condensing boiler is going to create water as it runs. Okay, one of the things we need to do, we need to trap that condensate, right? We need to allow the water to flow into it until we reach a certain amount of water, in which case the condensate is going to allow it to flow out. On an FTXL, the trap is located in the rear of the cabinet. It is integral. So condensation, again, so we need to capture that condensate, we need to expel it from the boiler. So people oftentimes are kind of surprised at how much condensate a boiler can make. So about 100,000 BTUs in condensing mode, you're going to get about a gallon per condensate per hour, okay? Very important that we handle that condensate correctly. You're going to see the third bullet point here. Larger units use larger neutralization kits, right? Every single condensing boiler that we install, whether it's code or not, is going to want to use a neutralization kit, okay? So here's a good slide that shows exactly how this gets laid out. The neutralization kits are not difficult to install, but they are important, okay? So as the boiler runs, again, we're capturing that latent heat in the heat exchanger. We're using that as energy to create efficiency, and one of the byproducts is that condensate. So you're going to have water, again, possibly a gallon per hour for 100,000 BTUs running out, and we need to dispose of that water. We need to get rid of it somewhere. So what we need to do is we need to get to a floor drain or a condensate pump, but in between those two, we need to put a neutralization kit. The reason that we use this is because the condensate that's created by combustion, due to the properties of the natural gas or the LP that we're burning, is acidic, okay? So for two reasons, we don't want to dump that acidic condensate into a public drain, a floor drain, or a condensate pump. Bad for the environment, first and foremost. We don't need to be pumping acidic water back into the water table, into our drains, into our sewers, where it's going to run back into the oceans or streams or whatever. Not good. Also very important to remember is that the acidity from an infrastructure standpoint is going to have an issue. So if you have a building where all of your drain pipes, older building maybe, are cast iron, over time the acidity in the water can damage those pipes. So for example, if you've ever seen anybody who tried to pipe a condensing boiler through the condensing water through like copper, it'll eat through copper in a very short amount of time. It'll turn your copper pipe into a canoe in law. So again, best practice is important. You want to use PVC, right? You're going to use a plastic which is not subject to the acidity in the water, and you're going to capture that condensate through the trap. You're going to run it through a neutralization kit. When it comes out of the neutralization kit, it is inert, right? It is now just regular water. The pH is correct. It's no longer dangerous to your building. It's no longer dangerous to the environment. The way a condensate neutralization kit works is essentially it's filled full of rocks, like pebbles, and this is limestone. So as the acidity of the water flows over these limestone rocks, the natural properties of the limestone counteract the acidity and it comes out the other side. Again, inert, safe to pump out into the public water supplies with no issues at all. Neutralization kits typically are inspected annually. Depends on how much the boiler runs. It depends on the fuel content, really. So again, best practices, it's not super expensive. You take your condensate neutralization kit, throw your pebbles in the garbage, and you'll fill it up with some new ones, and you'll be good to go for another year. Again, that's going to kind of be at the discretion of the installer. You can get a little pH test kit and test the outlet water, see how it's looking. Again, if it's coming out inert, your neutralization kit is still working, but if it's starting to trend towards the lower end of the pH scale, then you want to replace that neutralization media. Again, in the form of little pebbles. Okay, here's another condensate neutralizer. The one we saw in the previous slide was a cylindrical neutralizer, and this one is more of a kind of a bucket, right? A rectangular box. The difference between the two is basically the volume of the media that's in there. How much of the rocks or those little pebbles do we need in order to counteract the amount of condensate that's flowing through it? So we got a smaller boiler. It's going to use a smaller cylindrical neutralization kit, and a larger B2 input is going to require a neutralization kit that's shaped more like a little box, and it's going to hold more volume and allow more condensate to be neutralized. And again, reach out to us. We specify condensate neutralizers with every single piece of equipment that we sell. So we're going to give you the appropriately sized one for your equipment. If you have a question on it, which one do you need? Again, feel free, Wallace and we're happy to help answer that question. Okay, so piping. Okay, a couple different ways we can do our piping. Our piping can be installed, whether it's a new install or a replacement. Full flow variable technology. Full flow, essentially what that means is we're taking water from the pump, we're pumping it through the boilers, through the heat exchangers, and then out to the building to create our heat. So again, full flow, variable flow technology. This goes back to a water tube versus a fire tube design. Okay, so a fire tube boiler is going to allow you to install your boiler in a full flow or variable flow. Variable meaning we're varying the speed of the water as it travels through the heat exchangers to the building, or you can do what's called primary secondary, which is much more common. For a water tube boiler, we're going to require primary secondary. And to be honest, full flow We don't see a lot of that coming in on any sort of like new construction, but again, the fire tubes do give you the ability to do that. Again, you can save yourself some money on install, you can save yourself some money on material by doing full flow. But then again, generally speaking, we see more of that. Okay. So let's discuss, we talked about condensing. We talked about the boiler's ability to capture that heat in the heat exchanger to create that extra energy to get to that AFUE that we discussed, right? That annual fuel utilization efficiency. So the condensing is a big part of that. Again, we're capturing the latent flue heat and we're helping create extra hot water with that. One of the other things that the boiler is going to do, huge component to make it more efficient, is it's going to modulate its fire rate. And that's directly tied into something also called turndown, which I'll explain. So a variable speed boiler pump is very important on modulating boilers. Okay, so what this is going to do, it's going to allow our boiler to tell the boiler pump what speed it should be running at. Now, variable speed pumps with ECM motors are going to be regulated or required by law within the next handful of years, right? Because of efficiencies, right? The ECM motor requires a magnet to start. It doesn't have as big max inrush. It doesn't require as much energy to run. But for our purposes, the modulating variable speed pump is important because we are going to match the delta T of the boiler to the pump flow through the entire fire rate. Now, this ties back to turndown, right? So again, we have condensing and we have turndown. What the boiler is going to do is the boiler is going to modulate its fire rate. Okay, so this isn't an old school boiler where we have an on-off, right? Where we get a call for heat, the boiler turns on until it runs to whatever the aquastat tells it needs to be, and then it turns back off. Okay, or even old school 2 or 3 stage boilers where it's going to stage up and down between 25, 75, 100% fire rate, and so on and so forth. These boilers have the ability to land anywhere within their fire rate. So again, if you have 1 million BTUs and you have a 10-to-1 turn down, you can go down to 100,000 BTUs. Because do you need to run full boiler input every time the boiler comes on? The answer is absolutely not. You don't want to go turn the boiler on, pump 1 million BTUs of energy into your system, and then turn it right off. What we want to do, and what we do actually achieve, is we're going to turn the boiler on. It's going to begin to heat the water, and then based on information that the boiler is reading on its inlet outlet temperatures, it's going to begin to read and say, you know what, I have a set point of 140 degrees. The outlet temperature is at 125 degrees. Our return water is starting to heat up a little bit, and what it's going to do is it's going to modulate the fire rate. It's going to slow down, the fan speed is going to slow down the burner, and it's going to say, I don't need necessarily 1 million BTUs. Let's go down to 700,000 BTUs. As we start to get closer to our set point, it's going to continue to ramp down and down and down and down. Again, which gives us that efficiency, right? So we may only need on a certain day 300,000 BTUs, which the boiler is going to ramp down. It's going to run at its, basically it's slow and low. It's going to cruise along using as little fuel as it needs to satisfy the demand for heat. Think of it as city versus highway miles in your car, right? You don't want to jump in, go full throttle, stomp on the brakes, turn your car off, turn it back on, full throttle, stomp on the brakes. Again, this is important for a couple of reasons. The first is fuel efficiency. Again, it's much more advantageous to have this equipment running at a lower fire rate because you're using less fuel. But also, we want to reduce the amount of cycles on the equipment, okay? Because you don't want to just turn it on, off, because again, it's bad for the lifetime of the equipment. You don't need your igniters and your flame sensors and your fan motors and everything else getting worked 25, 50, 100 times a day, right? You want it to come on, you want it to run as long as it needs to maintain the required temperature, regardless of your method of input, and then turn itself off and put itself into standby. So that's for anti-cycling, that's for component lifespan, and that is for fuel efficiency. So there are a lot of benefits to doing it this way. The thing we need to remember is that we need to match the boiler delta T to the system delta T. And the way we do that is by using a variable speed boiler pump. So as the boiler starts to ramp up and down with its fire rate, if our pump is a fixed flow boiler pump, the boiler's still going to work, right? It's still going to heat the water. However, the problem is that you're going to start losing your efficiencies because your GPM is going to stay the same, but your input, your output at different firing rates is going to be different, right? So you're not going to be as efficient, okay? So using this example, fixed flow, you're going to see that the GPM stays the same, but the delta is going to be significantly impacted by the boiler's flow through it. So, oops, there we go. By using a variable flow boiler pump and a modulating boiler, we're able to maintain that delta T by varying the gallons per minute of flow through the heat exchanger to match the output firing rate. Okay, so again, on the night boilers, you're going to have a pump that's provided with the boiler. For our purposes here at Wallace Ennis, every time we quote you a boiler, we're going to recommend a pump that's going to go with it. It's going to be a variable speed pump that's going to allow those two pieces of equipment to work together to optimize your efficiency and to make sure that your equipment runs the way that we need it to. It's good to go. So we're going to take a quick break. We're going to do about 10 minutes. You guys take a bio break and do whatever you need to do. We will come back at, say, I got 10:55 on my laptop here. So say 10:05, we'll be back and we'll pick up. So thank you everybody for that. And we'll be back in 10 minutes. All right, everybody, we are back and ready to rock and roll. So let's make sure we get everybody here. Okay, so we're discussing design considerations for load matching. So again, the modulation of the boiler should always be matched to the pump flow, or vice versa. The pump flow should always be matched to the modulation of the boiler in order to make sure we maintain our constant delta, which in turn is going to help to keep us maintaining our efficiency and make sure the boiler is running the way that it should. Oh, sorry guys, just 1 minute here. Okay. Okay, so let's take a peek. Inside a night boiler, again, we are looking at a water tube heat exchanger. Again, this is for the night XL. We're gonna have a water tube. So here's a good example. If we're looking at the lower left-hand corner, you can see that there is a burner and there are the water tubes surrounding it. Again, so what we're doing here is we're flowing the water through the heat exchanger, and the burner is located inside the cylindrical heat exchanger, and it's exchanging the heat with the water. Let's see, just hear something open. Okay. Again, this is a stainless steel system. All of the heat exchanger you're going to see on the condensing equipment is going to be stainless steel. So why don't we use copper for condensing boilers? Well, as we discussed before, the condensation that's created by capturing that latent energy does create that caustic or acidic condensate. So only stainless is going to be able to stand up to it, and it will not corrode over time. Again, the heat exchangers are all AS&E certified. This is the inside of a night boiler, okay? So we're looking at the combustion system here as well. So this is a negative regulation gas valve. And when we discussed that modulation, one of the things we're going to do is we're going to speed up and we're going to slow down the fans. So as you're looking at this little excerpt of the inside of the cabinet, on the right-hand side, we have our gas piping that's supplying our gas, again, from 4 to 14 inches of water column. It's going to flow through the gas valve into the fan where it's mixed with the fresh air, right? That combustion air that we're pulling from outside, or possibly we're pulling from room air, depending on if you have enough room to satisfy the BTU inputs on the boiler. So what happens here is that the speed of the fan is going to constantly adjust the volume of the fuel in the air to meet the heating demands. So again, as low as 4 inches water column, that's not what we're shooting for, everybody. We want to shoot for somewhere in the middle. But again, what happens is the gas valve is simply going to open and the gas valve is going to shut once demand is satisfied. What happens is the back of the cabinet, you can see here that there is the fresh air intake, which is getting pulled into the fan. You're creating a Venturi effect, and the gas valve is going to snap open. The fuel is going to flow through the gas valve into the casting of the fan body, and it's going to create an air-fuel mixture, okay? As the fan speeds up and slows down, it's going to be creating a higher or lower air-fuel mixture, and it's going to allow the boiler to fire up and down. It's going to modulate like we discussed before, and that's what's going to get us our turn. Okay, so once the air-fuel mixture is pushed through that fan, it goes into the burner, okay? So now this is the night wall hung, the night floor, the Noble. This is a metallic fiber burner, okay? So now on old school non-condensing boilers, you would just basically have a flame like you would see on a tea kettle or a water heater or something like that. What we're doing with this is we're using a metallic fiber material. And again, this is the same kind of material we're going to see against all of the condensing equipment. The reason that we use a metallic fiber material is to create a lower temperature flame to create the same BTU input. And the reason we want to see a lower temperature flame is A, stress on the product's wear and tear, but also something called NOx compliance, NOx, right? So NOx is regulated depending on where you are in the country, either not at all, or on some parts of the country very strictly. So if anybody's calling in from the West Coast, you are well aware of your NOx compliance. Utah Again, they got big cities in the valleys down there, and it's very important that NOx compliance is there. So the thing about NOx is it isn't necessarily a ozone depletion air quality issue, it's a smog issue, okay? So we're not necessarily worried about the potential impact of the flue gases on our air quality for ozone depletion. I mean, that's the carbon molecule, it's a whole different ball of wax. But what we are doing with our NOx compliance is we're staying within our regulatory requirements for smog. So again, California, Utah, Texas, if I recall correctly, have very stringent NOx requirements. We're less populated areas, you're not going to see it as much. But again, the metallic fiber burner is going to allow the boiler to create the positive input. It's going to get us to where we need to do with our BTU inputs and not create smog. So again, the metallic fiber material may look a little different across different products, but again, you're not going to have any of the condensing boilers where you have just a direct impingement flame. It's always going to have one variation or another of the metallic fibers. And that's across water heaters, that's across boilers, the whole product line. Okay, so here's a stainless steel heat exchanger, fire tube designed. So this is for the newer Knights. This is not the Knight XL, and fire tube designed water back combustion chamber. So what's happening here versus what we saw with this one. So this is a water tube. Again, water tube, water is flowing through the tubes, and heat is being exchanged by the metallic fiber burner that's sitting in the middle of that cylinder. On our fire tube boilers, which again is the Crests, it's the Knights, the non-Knight XL product line, you're gonna have a fire tube design. And what this means is now you can see on the right-hand side, there's a little cutaway. The energy is coming through the top of the heat exchanger. We're creating that flame, we're creating that heat using that metallic fiber mesh, and we're pushing it down through a series of tubes where the water is surrounding it. So that's what we say we're doing the water back combustion chamber. And again, there's turbulence creating dimples. Why do we want to create turbulence in the heat exchanger? Shouldn't we just blast the heat straight through and let it go on its way? The reason that we want to create that turbulence is to make sure that we get our maximum heat exchange, right? So it gives the flame a little more time to dwell in the heat exchanger and make sure that we're putting that heat into the water rather than the flue, okay? So again, one of the pieces of the puzzle that when you put them all together, you get this high efficiency, that AFUE that we were looking at. So again, this is a good example too. You can see we've got our blower up on the top here. We've got our fresh air coming in from, again, outside or room air, pulling our gas through, creating the air fuel mixture, creating that flame, pushing that energy down through the heat exchangers, through the fire tube heat exchangers. As that flame or that heat goes to move through those baffles, those tubes, what happens is it comes in through the top in a flame state, right? And as it moves down through, you've got your cooler water coming in through the return, you've got your heated water going out the top. So what's happening is the cooler water, again, ideally you're going to want to be in about the 130-degree range, cooler the better, is changing the flame's state inside the heat exchanger, okay? So again, it comes in as a flame, it comes out as condensate, it gets collected in that tray and sent on its way. Here's a nice cutaway. Again, this is a flame tube. We have those dimples, you can see those clearly. Again, the purpose of the dimples is to maximize our efficiency for heat exchange. Okay? We don't want to just blow the flame in and send it on its way. We want to kind of slow it down a little bit, create some turbulence, really let that water that's backing up these heat exchanger tubes exchange that energy. Okay, again, this is all goes down to efficiency. Okay, so controllers, we have the smart system. Okay, so the smart system is going to be installed on the Knights. It's going to be installed on the FTXLs. Going up to the Crest, you have a smart controller, which is like a almost like a little laptop in your hand. It's amazing. It's like an iPad. So smart system is going to allow us to set up the boiler We're going to do our method of control. You can do domestic hot water priority. You can run freeze protection, alarm contacts, clock data logging, safety controls and indications. All of them are password protected. Nice thing about the password protection is that you get the same password across all the product lines. So you don't have to remember like 10 different passwords. It's all the same password. Now, let's touch on that outdoor reset outdoor air sensor. It's available through here. Let's see if I have one, and we'll come back to it. So outdoor air sensor, when we talk about an outdoor air sensor is included with all of the boilers that you're going to buy. The advantage of an outdoor air sensor is going to be you can hook this up and you can tell the boiler essentially what the temperature of the outdoor air is. The advantage of this is that it allows the boiler to really maximize its modulation and its turn down. Okay, so when we install the outdoor air temperature sensor, we can tell the boiler that it is 25 degrees outside, it's very cold, we need to heat the space, and the boiler is going to take that information, and again, running algorithms based on its inlet and outlet temperature, it's going to run at a higher fire rate, because at that point, the boiler is going to calculate that it needs more energy to satisfy our requirements for our space heating. As that outdoor air temperature begins to increase, it's going to read the outdoor air temperature, and then conversely, it's going to say, I don't need as much heat. This is particularly useful in areas of the country where we do have a solid 4 seasons. The shoulder months, this is tremendously helpful for fuel efficiency. So again, I'm located in northern New Jersey. So during, say, September through the end of November, it's chilly in the morning, but it's warmer in the afternoons. So again, the boiler doesn't need to just be dumb and output whatever its outlet temperature is and just do its thing. Based on the outdoor air temperature, it can run at a higher input when it's colder in the morning and then slow down in the afternoon when it gets warm till we get to a point, typically 70 degrees is where we want to see it, where the boiler says, I don't need to run at all. Okay, so the boiler is going to know when it's warm out and it's not going to run. And again, this is one more piece of the puzzle of how we get that efficiency is using an outdoor reset. Now, having said that, the sensor that we use that's sent in with the kit when you get your boilers is a wired sensor, right? You're going to run like an 18-3 bell wire back to the boiler and land it at the low voltage terminal strip and tell the boiler what the outdoor temperature sensor is. The outdoor air temperature sensor should not be mounted anywhere but the north side of your structure, right? Typically not in direct sunlight, because that's going to kind of give a false reading. It's going to tell the boiler that it's hotter or colder than it really is. And it's not always easy to do. You know, sometimes you've got a long run towards the north side of the building. Sometimes you've got structural stuff. You got poured bluestone. You got a whole bunch of stuff you need to punch through. You can get, as an aftermarket piece of equipment, a wireless outdoor air temperature sensor that will speak to the boilers that you don't need to snake that wire through the structure if you're unable to get to that north side of the building. So kind of skipped ahead a little bit. Let's go back here. So again, the smart system is kind of showing us what you can expect to see from it. Smart system, again, domestic hot water recirculation pump. You're going to have a low voltage terminal that's going to tell that pump when it needs to run and when it doesn't. Cascade redundancy. Okay, so all of the equipment that Lochinvar makes has the ability to run as a boiler plant. Okay, so you can link together multiple pieces of equipment and you're going to tell them that they're running as a plant now. You're going to set it up as a leader and a follower. And what's going to happen is you're going to have multiple pieces of equipment now running to satisfy a demand. And what you're going to end up doing is you're going to running a system sensor, which is landed on the manifold for the system on the outlet of the boilers, and you're going to run that back to the leader boiler, and it's going to tell the other boilers what their fire rate should be. So why do we need more than one boiler? Well, because a couple of reasons. The first and foremost is redundancy. Okay, if you're in an application, whether basically anything outside of residential, you're going to want to have the ability to have 2 boilers that are able to handle the load. So let's say you had, for whatever reason, catastrophic failure on one of the pieces of equipment, you don't lose the whole building, right? You still have the ability for the other boiler to kind of limp along and carry that load until the other boiler is repaired. Also, again, for efficiency purposes, you're going to want to run these boilers together. So, you know, believe it or not, you're going to have some people who will argue with you about it. It is significantly more efficient to have two boilers running at 25% of their input than it is to have one boiler running at, say, 50 or 60. And what the boilers are going to do is they're going to sequence themselves, right? So they're going to say, all right, this boiler's running a little too hot. Let's run two boilers down at the lowest fire rate possible. So again, that's what we're always striving to do, is to make sure we're using the least amount of fuel to create the correct amount of energy, okay? So again, irrespective whether you're using outdoor air or whether you're using a system sensor for constant set point, this cascade redundancy is tremendously helpful. It helps our fuel efficiency, and it also gives you the peace of mind that if you do have a failure, you need to shut down for service for one of the pieces of equipment, whatever the reason is, you never lose the building. And if any of you have ever been in a position where somebody value engineered their building too much, they had one boiler that went down in the wintertime, it's not pretty. So again, cascade redundancy is very, very important, and you almost never see a single boiler go in anything outside of a residential application for that reason. Again, efficiency and redundancy. Okay, so here's a capture of the smart system. Yeah, the smart system it's in English, okay? All of the controllers that you get on Lochinvar are meant to run where the UI is almost like an iPhone or an iPad, right? When you get this thing out of the box and you set it up, you're not getting a million different things where you need to be an engineer and you need to dial down through 100 different submenus to set it up. It's going to have a wizard that's going to tell you to go through, and it's going to ask you what you want to do, and you're going to set it up, and it's very simple. So here's an example of the smart system in play. This is a system that's set up for space heating with domestic hot water recirculation. It's telling us outlet temperature on the flue, outlet temperature on the boiler, inlet temperature to the boiler, what the fire rate is, our inlets and our outlet on our tank, and the outdoor air temperature. So a lot of information is packed into a very small screen. And again, tremendously well done on the smart system. And the touch controller on the Crest is equally as good, if not better. And again, remember, all these boilers speak English. You're not going to have to interpret like flashing lights and codes. Like an F7 with 3 yellow blinking, it means X. It just says, this is the fault, this is what it means. It makes troubleshooting and setup very, very simple. Okay, so here we go. So Connexus is offered for free across all of the product lines, from the ninth up to the biggest condensing boilers and water heaters we have. So what is Connexus? Okay, so Connexus is an app that you can download on your phone, and what it is essentially it's like a mini building automation system. You can go in and you can see what's going on with your boilers at any time. Okay, you can see the fire rate, you can see what the faults are, you can do some setup. I mean, you can't do life safety stuff, like you can't reset a fault that could potentially be dangerous, but this is really good for a couple of reasons. As a former mechanic, you know, like we would get calls and all you get is, oh, it's broken. So now you're driving out in your truck at, 11 o'clock on Friday night. And you're like, well, what could it be? Do I have an igniter? Do I have a flame rod? Should I bring my manometer? Well, the answer to all 3 questions is, yeah, you should have them. But it gives you the ability to forecast, right? You have that remote access and you can see what the boiler's doing. You can see what's happening to it. It's very, very helpful for customer retention, okay? So you can see what's going on with stuff. You know, if you are selling service contracts, this is a great way to get people in and say, you know what, you guys are up for annual maintenance. We can see maybe that your fire rate's a little higher than it was. We should take a look at the equipment, and it allows you as a contractor to get in there and really service the equipment well. And from a rep standpoint, it also, I mean, I have a lot of accounts that we work with that I have access to their Connexus, and it's just, I mean, again, it's for forecasting and troubleshooting and maintaining the equipment. It's invaluable. Again, the cloud service is free. The controller is standard on pretty much everything going forward. On older equipment, you can add it as an add-on, But all the new Lochinvar equipment going forward is going to have the Connexus that's native to it. Okay, here's a screen cap from it. Again, you can see everything that you can see from the controller. Okay, you can see your set point. You can see what fire rate the boiler or water heater is at. Outdoor air temperature, hot water system supply system return temp. All that information is at your fingertips. Again, and this is remote. You don't need to be standing next to the boiler to do it, okay? What you need to do is make sure that you have a Wi-Fi signal and a good approximation to the equipment, and then you're done. You do your setup, and you have that boiler plant right there. And again, you can do multiple boiler plants. It's not as if this is tied from one application to one install. You can have all of your customers, you can see what's going on with their boiler or water heating plants remotely. And again, tremendously helpful for that. So I'm going to roll into maintenance and service. Okay, just checking that. Okay, so for startup, residential light commercial stuff, startup is fine. You're going to basically go through the steps that are outlined in the manuals. For anything, say over, I don't know, 400,000 BTUs or so, we can quote you a factory startup. Wallace Ennis has a full staff of factory trained technicians who their job is to do startups, right? And what they're going to do is they're going to come out. We're going to review your venting. We're going to make sure the pumps are set up correctly. We're going to make sure that your condensate is being handled in the proper fashion. We're going to turn the boiler on. We're going to help do the programming. And we're also going to do a combustion calibration, make sure the boiler's running in the way that it needs to, and so forth. Again, if you're a skilled contractor, this is stuff that you're comfortable with. You've been doing it for years. It's not necessarily a requirement. You're not going to void a warranty by not doing a factory startup. But large commercial equipment, we're going to always recommend that you have our people do it, again, because we're factory trained, and it just gives us that extra peace of mind and gives everybody that peace of mind. So again, as a service technician coming in, you're gonna ask your end user, have you had any issues? Were there noises? Were there any spots where the building wasn't heating properly? We're gonna go through, we're gonna inspect the interior of the cabinet. Again, clean and vacuum if necessary. You shouldn't really see too much accumulated stuff inside the boiler cabinets if the boiler space is clean and we're pulling fresh air from a good area where we don't get outdoor contaminants. We're going to check the condensate trap and refill it. Again, condensate traps over time, they can get kind of junked up, so that is important to do. You're going to blow it out, you're going to refill it, and you're going to make sure it's full of water. Flue and air lines in good conditions and sealed. Again, this is just kind of giving it a once over. Water pressure, system piping, expansion tank. Most guys are going to walk over to the expansion tank, they're going to tap on it, it's going to sound hollow, they're going to be on their way. And this is good practice. And again, we have the ability to help you guys with your annual maintenances. If you have questions, we can meet you on the job site. We're happy to do so. For maintenance and service, we're going to check the water meter. We're going to check the boiler water. Excuse me. When test indicates clean system water, the boiler is perfectly happy. And again, remember that this is a closed loop system, right? So the boiler should never have any more or less water than it did on the day you started it up. If the water fill, the water meter is running into the boiler, that means you have a leak, right? Also, it's very important to remember that in a lot of areas of the country, my segment, geographically particularly, has extremely hard water, right? A lot of lime, a lot of calcium, a lot of stuff building up. DC metro area, Virginia, also terribly bad with this. You may want to look at doing some water treatment and some remediation, essentially, on your water. So again, check your controller. You're going to go through, check your igniter and your flame sensors. Clean, reposition. It's not necessarily required for you to change your flame sensor and igniter yearly. However, it's good to have one on hand, especially if you have a boiler plant where you have, 4, 8 different boilers on hand. You're probably going to want to have a box, a couple flame rods, a couple igniters on hand in the event that you need them. But for a smaller single boiler application, ordinarily you can just kind of take out your flame sensor, sand it off, clean it, and put it in, and you're good to go. Okay, so I just finished talking about water quality and closed loop hydronic systems. And again, it's a closed loop for a boiler. For a water heater, obviously we're taking water in from the street, we're heating it, we're sending it out to our building through our faucets and fixtures. But for a boiler, we're going to install our boiler, we're going to fill the system full of water, and then barring any construction where we got to open up the system or leaks, the closed loop should have the water in it from the day that it was born. Now, water quality can be a big issue. If you're doing new construction where you have all new piping, makes your life easy because you can kind of flush it out, fill it full of water, close it off, and it's good to go. But oftentimes what you're going to run into is you're doing swap outs on the fly where people didn't maintain their equipment, and now you're there in the middle of December getting screamed at because you need to change things right away. It's very important in those situations to take a look at the water that's in your system. Okay? You can have pitting, scaling, blockages, sludge, film, and this is again a tremendous loss of efficiencies. So you can have the most efficient boiler in the world, but if the pipes that the water is running through are filled full of sludge and film and blockages, the boiler's nothing to boiler with. All of our turndown, with all of our modulation, with all that condensing technology doesn't mean anything if we're running it through very inefficient piping. So that's something to keep in mind on older systems. Again, if you're doing like an emergency swap, like a chop and swap, take a look at the piping when you cut the old boiler out. Try and pull some water out of there if you can. Again, premature component wear and breakdowns for sure. Reduction in heat transfer, 15. Boiler efficiency after only 3 weeks, you're going to lose quite a bit of efficiency. And again, as good as the boiler may be, if you have pipes that are coated in slime and biofilm and magnetite, you're not going to be in good shape. So again, low flow. So again, not your father's boiler. We kind of discussed that before too with water tube boilers. Again, it's a narrower passage, whereas on an old heat exchanger, it was like a tea kettle, right? You can fill that thing full of freaking Skittles. It's not going to really care. It's just going to run and boil the water and send it on its way. When we're talking about efficiency, particularly with water tube equipment, if those water tubes are running and they're getting full of lime and scale, again, it's going to clog, it's going to be inefficient, you're going to have failures, and you're going to basically lose all the advantages that we had from that condensing technology due to bad water. Okay, so again, the circulator pump, when we talked about matching the boiler turn down, the boiler fire rate to the speed of the pump, we achieve that by using an ECM pump, right? So an ECM pump or electrically commutated motor is going to vary the speed of the pump, and it's got a big old magnet right in the middle of it, right? So if you've ever pulled the boiler out and you've seen that black sludge, let's see if we have an example of it. That's called magnetite, okay? Magnetite is, again, it looks like black, almost like mud. And you're going to see that very commonly in buildings where you have cast iron pipe carrying your boiler water. So over time, due to friction, oxygen impingement, whatever, that black sludge is actually like microscopic particles of iron that's been kind of sludging off the inside of your boiler system for as long as it's ran. So again, you don't want that running through your pump. You don't want that running through your heat exchanger. So you need to take some steps to kind of delineate that if you're able. So again, oxygen ingress, dissimilar metals in direct contact, right? So again, using dielectric unions, if you are using old cast iron pipe and your new boiler is using a copper header, you want to 100% make sure that you drop the cash and use those dielectric unions, because again, they will create an issue over time. And again, sludge fouling, oxygen ingress, these all could be pre-existing in boiler jobs you're going in to do, right? Again, new construction, you got a new house, you're putting a McMansion, you got an FTXL or a Night XL, something like that going in, you're probably going to be fine. You're going to refill with clean water, you can put a treatment in, and you shouldn't have any issues. What we're talking about here again Older systems, again, I'm on the East Coast outside of New York Metro, lots of old buildings. So the potential for these kind of contaminants and sludge and magnetite is tremendous. One of the ways that we can do this is using something that's called a magnetic filter, okay? So the Sentinel Vortex Residential comes in 3/4 and 1 inch. And we have the boiler mag product, goes up to 1.5 inches, and it's off into the world. I mean, 4 or 6 inches, whatever you need. Essentially what's happening here is that you're using this as a filter, right? So the water is going to flow through your boiler plant. It's going to go over these magnets. And what it has is a rare earth magnet that sits in the path of the water. And any of that magnetite, any of that scaled down, sloughed off iron that's in your water is going to stick to that magnet. And you're going to be able to isolate this. You're going to pull it out. You're going to rinse it. You're going to put it back in. And over the life of the system, this will completely take all of that out of the water. And again, if you are running a new condensing boiler with a big ECM modulating or variable speed pump on it, you're never going to get rid of all the magnetite because it's basically the system running through the cast iron pipes will create it as it runs. This will protect your pump. This will protect your boiler. Again, I can't stress enough, water quality is very, very important when we're talking about condensing boilers. Okay, so again, this is a Boiler Mag XT from 1.5 inches up to 12. Same principles, a bigger magnet, you can get flanged or threaded. Now, water treatment, we're going to talk about the Sentinel line of products, and this ties in with our magnets for sure. Okay, so again, if you have an older system where you may not have the time to properly flush and restore it, you can use the Sentinel X800 cleaner, right? So now, if you have the ability to spec a job where you have a customer who has an old house and old house building, doesn't matter what have you, you can come in before the day that you're going to demo and do your swap. You can let some restorer run through the system, and then you can drain it and you can fill it and you can treat the water, and that's absolutely perfect. But as we all know, very rare for us to be running into ideal conditions as contractors or mechanics. The X800 can clean the system in an hour. Okay, so if you have an emergency situation in an old building with cast iron pipes, and you're going to be putting in a condensing boiler, we're going to quickly remove the corrosion. We're going to put in this X800 cleaner, and we're going to flush it, and we're going to be good to go. The water doesn't need to be hot. You can run it while the boiler is cold. As long as you have flow through the system, you can introduce this to your system, and it's a fast-acting cleaner. Okay, on newer systems, we can use the X300. Again, this isn't necessarily getting rid of magnetite and sludge and all that other stuff that may be in an old pipe. But what you do have on a new install is stuff like guys who got a little too aggressive with their flux. Maybe, we all know that guy who's got the big tub on his truck and paints it on like he's a Renaissance painter. Absolutely helpful to do this. Again, this is for a new heating system. It's going to get rid of any manufacturing grease, any of the stuff that may be in the pipes prior to startup. And again, the X300 is going to be something that you're going to use when you have the ability to kind of get in there beforehand and do things thoroughly. X800 is more of an emergency treatment where we're going to go with it. So the X100 we're seeing, again, which is the rapid dose can. We do have rapid dose cans available for a lot of the Sentinel product lines. This is really super helpful, okay? So 1 can of the rapid dose inhibitor typically is good for 1 residential installation. So what you're seeing here is a can, it's pre-charged. What you're gonna do is you're gonna snap that thing off, you're gonna mount it to the top of the can, you're gonna screw it onto a boiler drain. You open the boiler drain, and then you crack the can, and it's actually gonna push the treatment into the system. You don't have to shut anything down. You don't need a chemical pot feeder, okay? And then you can treat the system again, just strictly through the boiler drain. You don't need to do any repiping. You don't need a chemical pot feeder. It is super, super helpful. Again, inhibitors are going to be against limescale and corrosion. Again, in my area of the country where I am, You can use it for hard water, soft water, artificially softened, doesn't matter. This is going to help to get rid of that corrosion and that lime scale. Again, very important if you live in an area of the country where that's present. And you know what? It's equally as important if you don't. You can treat the water and you can keep it running nice and clean. We have examples of this where we put a steel nail in a jug of water and we keep it there, and we have a jug of water with the treatment next to it, and they simply do not rust. It inhibits the breakdown of the materials in the system, and it's tremendously helpful. So a lot of people will treat water treatment and the magnetic filters like it's snake oil. Oh, I don't need that. I've been installing boilers for 40 years. That's snake oil. It's nonsense. Like I said before, on an old cast iron atmospheric boiler, it wasn't that critical. But you're not installing old cast iron big heat exchangers that look like tea kettles. What we're doing is we're installing a smaller volume of water on a high efficiency piece of equipment. So it is actually imperative that we have clean water flowing through our equipment to, again, ensure that efficiency, to make sure that we don't have premature failures, and make sure that we get the best value for the product we're offering our customer. The inhibitor level test kit, again, it's like a pool test kit, right? Annual maintenance, you can come through, you can check, make sure that you have the correct amount of that inhibitor in. It varies a lot. You may need to add inhibitor once a year. You may need to add an inhibitor every other year. If you have a couple cans on your truck and you have a quick test kit, by all means, use them. Ensure that the investment that your customer or you as an equipment owner have made stays important. Now, I will say, just to kind of close on that, the magnetic separators and the water treatment, my biggest fans, the contractors and the wholesalers that I work with who really kind of advocate for these, are people who have lost heat exchangers to hard or poor quality water, for sure. You know, and again, like I said, I've been in the industry since 2000, and I'm not that old, but I am a little old school. And you know, you hear people just kind of scoff at it, but you have to remember, this isn't your old, this isn't the old school boiler. So do treat the water. And again, please, I can't reiterate enough, I'm available to help. If you have a question, reach out to us. I'm in North Jersey. Again, we cover all of New York Metro out to the tip of Long Island, down to South Jersey. If you're in our region, we have somebody local who can talk to you about this at length and tell you what your best selection is going to be. Okay. So we're going to kind of go through a couple of decks here that are going to show us basic igniter replacement and some other kind of maintenance type of things. Now, what we're looking at here, and I'm going to kind of break and show you guys Locknbar University toward the end. This is a video that is taken from Lochinvar, and that's kind of what we can expect.
Begin by removing the top access panel and lifting it up and away from the unit. Then remove the wires from the ignition probe, flame sensor, and ground terminal. Using a TX20 Torx driver, remove the two screws holding the ignition probe in place. You can now slide the ignition probe out of the combustion chamber door by lifting it up and away. The gap between the ground probe and the ignition probe on the replacement igniter is greater than the original to prevent sparking on the upper section of the probe. This can make it difficult to slide.
What's going on? All right, so we're loading here. Looks like we're having some technical difficulties for this. So I'm just going to kind of talk over this one. So igniter replacement, as they're saying, the spark gap may be different on the igniter that you received versus the original one you took out. Again, not always necessarily critical for you to replace the igniter on a piece of equipment. You can inspect it, you can see how it looks. Things that you want to be aware of with your igniters when you're replacing them or when you're inspecting them is just fouling, making sure that there aren't any kind of cracks in the porcelain. Right, so when we're looking at the slide, you see the guy's got his left hand, he's holding the porcelain. outside portion of the igniter. You just want to get out your flashlight if you have old eyes like I do, and just make sure that the porcelain is entirely non-corrupted, right? There's no kind of like spider webbing on it. There's no cracks. Make sure that the spark gap looks appropriate to you. Again, have one on hand in case you need it. But again, the flame rod and the igniter are going to be inspected annually, not necessarily critical that you replace it. If you pull it out and it looks like the day you put it in, it will continue to run. But always have spares, especially if you have a large commercial plant where you have a cascaded bunch of boilers, a big bank of boilers or water heaters. Always have extras on hand. Just best practice, and it'll save you a bunch of headaches. So maintenance and service, we're going to go through, and I know it sounds kind of simple, but check wiring and connections. You know, really kind of do that. Take a minute to make sure that your spade connectors all look solid. Nothing's kind of vibrated loose. I mean, not that you see a ton of environmental vibration, but you know, the blower or something like that, if you've got bad combustion, can create vibration towards the fan, and it is possible for stuff to kind of go through. So startup, checkout, and performance verification, you're gonna visually inspect the flame. And again, you know, a lot of people will tell you a lot of different things, right? So if the flame is too orange, it's too fuel rich. If it's too blue, it's too oxygen rich. So you want to kind of be somewhere in the middle. The best way to do this is to verify that with a combustion analyzer, which we're going to talk about a little bit too. So again, you're going to check your flame signal. Again, you're going to need a meter that's capable of reading microamps, right? Very simple to do. You just disconnect the lead spade connector from the flame connector, and then put one end of your meter on the flame connector, the flame sensor, and the other half onto that connector, and run the boiler, right? So easy enough to do. Clean the heat exchanger at the flue temperature is more than 54 degrees above the return water temperature. Again, that's a really good sign. You're going to see your delta T is going to start to drift. It's not something that you want. Okay, so again, cleaning the heat exchanger, cleaning the blower, and removing and cleaning the burner. Generally speaking, if the boiler is installed correctly and you don't have like animals living in your fresh air intake, or smoke or dander, or like those guys or girls that we saw having that lint pulling in right next to the fresh air intake, really shouldn't be something that you need to do often. Okay, if you do need to remove and clean a burner, you're going to use compressed air. You're going to use the gentle compressed air. Remember, we have that fiber mesh. You're going to inspect that fiber mesh. The fiber mesh should always be tight to the cylinder. If you hold it horizontally, you shouldn't see kind of sagging. There shouldn't be any gaps. And when you do look at that mesh, also remember that it is like it's a woven mesh. Kind of keep your eyes out where if you see anywhere where that mesh is kind of torn looking or pushed apart, if one piece of the mesh looks like it's significantly larger than somewhere else, then you're just going to need a new burner at that point. But that's going to be one of the things you look at. Again, if your combustion analysis isn't right, you're looking at potentially a bad blower. You could potentially have a clogged heat exchanger, or potentially the fins on the blower wheel have been corrupted. Again, pulling in stuff that shouldn't really be there from your combustion. Okay. Okay, so we're going to go here on the Crest. This is the Crest heat exchanger cleaning.
Heat exchanger access and cleaning. The information contained in this video is intended as an aid to a qualified installing contractor or service technician. It is not intended to replace the installation or service manuals that are supplied with the equipment. Grasp the upper front panel at the bottom sides. Pull the panel away and up from the boiler. Grasp the lower front panel at the top sides. Pull the panel away and up from the boiler.
Locate the on-off switch on the lower left side of the control panel. Turn the switch to the off position. Turn off the main gas supply to the boiler at the main manual gas valve. Remove the top access panel by pulling up on the handles and lifting away. Remove the 4 Phillips head screws securing the top back panel to the boiler. Remove the panel from the boiler. Remove the 4 bolts and nuts from each gas-air manifold. Remove the 5 nuts securing the gas-air manifold to the burner. Carefully lift up and remove the gas-air manifold from the burner. A gasket is used to seal between the gas-air manifold and the burner. Care must be taken not to tear or damage the gasket. If the gasket is damaged or torn, then it must be replaced. For the 3 and 3.5 million BTU models, remove the 8 nuts securing the burner to the heat exchanger door. Pull the burner up and away from the boiler. Use caution when removing the burner to prevent damage to the refractory mounted on the inside of the heat exchanger door. A gasket is used to seal between the burner and the heat exchanger door. Care must be taken not to tear or damage the gasket. If the gasket is damaged or torn, then it must be replaced. Remove the wiring from the igniter and flame rods. Remove the insulation blanket from the top of the heat exchanger. Remove the nuts and washers securing the heat exchanger door to the heat exchanger. Pull the heat exchanger door up and away from the boiler. Use caution when removing the heat exchanger door to prevent damage to the refractory mounted on the inside. A gasket is used to seal between the heat exchanger door and the heat exchanger. Care must be taken not to tear or damage the gasket. If the gasket is damaged or torn, then it must be replaced. Inspect the heat exchanger surface and combustion chamber wall for any soot deposits or dirt accumulation. Using a vacuum cleaner, remove any loose debris from the heat exchanger. Brush the heat exchanger surface, flue tube entry points, and the combustion chamber wall using a nylon bristle brush. Re-vacuum the heat exchanger to remove debris. Remove the condensate drain line from the condensate trap and route directly to a drain. Rinse out debris from the heat exchanger with a low-pressure water supply. Once the cleaning is completed, reconnect the condensate drain line to the condensate trap. Reinstall the heat exchanger door back onto the heat exchanger. Reinstall the nuts and washers securing the heat exchanger door to the heat exchanger. Do not over-tighten the nuts when reinstalling. Tighten the nuts to a torque setting of no more than 15.5 pounds. Replace the insulation blanket on top of the heat exchanger. Reconnect the wiring from the igniter and flame rods. Reinstall the burner with the burner gasket back into the heat exchanger door. For the 3 and 3.5 million BTU models, reinstall the 8 nuts securing the burner to the heat exchanger door. Do not over-tighten the nuts when reinstalling. Tighten the nuts to a torque setting of no more than 6.2 foot-pounds. Reinstall the gas-air manifold and any gaskets back into the burner. Reinstall the 5 nuts securing the gas-air manifold to the burner. Reinstall the 4 bolts and nuts from each gas-air manifold. Do not over-tighten the nuts when reinstalling. Tighten the nuts to a torque setting of no more than 6.2 foot-pounds. Turn on the main gas supply to the boiler, the main manual gas valve. Turn the on-off switch to the on position. Press the main menu button to bring up the main menu screen. From the main menu screen, press the service button. To access the service screen, the installer passcode must be entered correctly first. The installer passcode is 5309. Using the keypad, enter the passcode into the display. When finished, press the Enter button. Once accessed, the service screen will allow the control module to override any previous heat demands and operate at a selected firing rate. To place the boiler into service mode, press the green Start button. While in service mode, the control module will ignore all other demands. However, all safeties will remain active. If no other buttons are pushed, the control module will automatically revert back to its original state after the service mode delay has expired. The default time for the service mode delay is 40 minutes. The boiler will light and modulate to its low fire operating condition. Press the total boiler maximum input button. Once the boiler has modulated up to 100%, use a leak test solution to check all connections for leaks. Seal any leaks before placing the boiler into operation. Once the testing is complete, press the red Stop button to take the boiler out of service mode. Press the Home button to return to the home screen. Replace the top back panel on the boiler. Install and tighten the 4 screws securing the panel. Replace the top access panel on the boiler. Replace the lower and upper front panels on the boiler. The boiler is now ready to accept a heat demand. If there are questions regarding this procedure after reviewing the video, the installation and service manual, please contact the Lochinvar Technical Service Department.
Okay, so that's a good overview right there. Crest heat exchanger cleaning. Important to remember too, the videos that we have been watching, the one that worked, we're from Locknbar University. We have a slide that's going to cover that. And again, Locknbar U is tremendously helpful. You're not going to get spammed to death with marketing material either. There are videos like that one, 5, 10, 15 minutes tops, that walk you through all these procedures. So again, very helpful. If you're interested in Lochinvar, maybe you got to do a maintenance, you've never done one before, you're going out the next day, spend a half an hour kind of familiarizing yourself with how to do these procedures. Again, they're extremely well done. There's a ton of really good information there. So one of the things, and again, this is crucial, is combustion analysis. If you don't have a combustion analyzer on your truck, you need to get one. Like I said, I've been working with condensing boilers for quite some time. I did tech support at Airco when I first came on there. And there are some things that you cannot resolve without a combustion analyzer if you're working on high efficiency condensing modulating boilers. So combustion analysis, again, we're going to turn the power off to the unit. We're going to move the flue temperature sensor from the flue pipe connection and turn the power on. We're going to go into standby mode and we're going to fire the boiler. And we're going to read the oxygen and the O2 and the CO2 values in the flue gases to make sure that the boiler is running properly. For a lot of the boilers, a lot of the residential boilers where you're going to see PVC installations, there's going to be a threaded analyzer probe cap right there. So you can just go in and get that done. Okay. All right, so combustion analysis again, natural gas. we're going to want to see our O2s between 3% and 6.5. Propane between 4 and 11 and 6.9 on our O2, 9 to 11 for CO2. The boilers are set up to run for sea level when they come out. And most often when you set a boiler up, it's not going to need a whole lot of tweaking. However, if we have anybody joining us from the mountain time zone where you're up at a higher elevation, you almost certainly you're going to have to do a combustion analysis, and that's very important. So again, a combustion analysis is going to be something that we're going to do during our annual maintenance. Again, that can give us a really good idea of what we're seeing with how the boiler is running as far as efficiency is concerned. So we are actually not talking about residential equipment today, so we're going to skip the slide with the noble domestic hot water heat exchanger cleaning. Again, if you are doing commercial and residential, this video is available to you on Lochinvar U for sure. So again, owner maintenance, really not much to do. This is very basic rudimentary stuff we're going to go through. And again, if you're retaining your customers like you want to, you're going to do this through. So again, you need to look for leaks. You're going to check and make sure that the relief valve isn't you know, dripping or hasn't popped off. There's no water standing on the floor adjacent to the boiler. Troubleshooting. Again, we don't need to go through and read each one of these list by list by list. There are troubleshooting matrices in all of your materials in your OEM manuals. They're going to walk you through here. Again, I don't think for time purposes it's going to be helpful for us to read each one of these through. And this is Lochinvar U, as I mentioned before. Lochinvar U, again, the registration is free. It doesn't cost you anything, and you're not putting yourself in jeopardy of getting like solar panels. They're not going to try and sell you an auto warranty. They're not going to try and sell you pills. It's strictly in place to help mechanics and contractors learn about the equipment and do best practices. And it is not only limited to, you know, stuff like we were just looking at, right? So it's not just how do you put the password in the controller, although that's there. They show you all the heat exchanger cleanings, right? How to do combustion analysis. But there's also segments in there where you can learn from the most basic principles of, we talked about full flow versus primary secondary flow. That there's a segment on that where they explain it. If you have an outfit where you have apprentices coming in, they have basic stuff of how to use a meter, you know, basic electrical theory, piping, gas sizing. There are calculators that you can use to calculate your required expansion tanks. So again, I can't stress enough. I mean, I know I'm the Lochinvar rep, but again, I've been in the industry for a long time. It's super well done. It's easy to digest. You're not going to be stuck for 2 hours listening to somebody drone on. Just became really self-aware after that statement. Sorry, everybody. So again, LochinvarU.com. I strongly urge you. I appreciate your interest in our products. If you're not already registered, definitely do. So that concludes us. Again, Lochinvar has the broadest product of condensing and non-condensing gas boilers and water heaters. Wallace Ennis is a representative for the Northern New Jersey, New York Metro, 5 boroughs out on Long Island. This was not meant to be an exhaustive, teach you everything about the boilers. Hopefully everybody got some good understanding of the fundamentals on how this systems work and what condensing and turndown is. Wallace Ennis is here to support you. Again, I'm the Northern New Jersey. We have somebody in your area, if you're in the New York metro area, that can come out and help you size up your systems, talk about water quality, talk about magnetic filtration, help you lay out your venting, whatever it is you need with regard to Lochinvar boilers. We are there and we're happy to help you. So please feel free to reach out. Everybody has our contact information in the invite from the original email. Otherwise, everybody, happy St. Patrick's Day. Feel free, you know, you can email us directly with questions. And again, I'm happy to come out and meet you in person and do walkthroughs and help us get some Lochinvar equipment installed correctly.